and there's going to be talks about the airborne observations that were made both at Grand Mesa, so during the IOP as well as during the time series. So super excited for today. You've had a lot of material. It is going to be a bunch more material that's new, and I guess to maybe reiterate what Micah had mentioned, which is don't necessarily worry about understanding every possible detail. We're providing you with a big resource, and you should be able to navigate to this resource moving forward. So just keep that in mind. This morning, we're going to talk about open source science and how that kind of fits into NASA mission development. So that's going to kind of be the next 25 minutes or so. I've got about 14 slides. I'm going to try to do a little interactive activity first to kind of wake you up this morning. So I'm going to just think for a minute about 3 or 4 words that might describe SnowEx to you or why you might be interested in SnowEx. So something really short, and we're going to enter that into the general channel on Slack. And I'll do the thing Naomi did, which was give you a minute or so, 30 seconds to think about what you're going to enter. What is SnowEx? Why is it important to you? Just to get the juices flowing this morning. And then I'll go 3, 2, 1, go. Okay, so hopefully folks are seeing some comments from the audience, and you've got a little bit of a better feel about what SnowEx is, why it's important, kind of what we're trying to do. I mean, at a very 10,000 foot level, we want to know how much snow there is, where and when it's going to turn into water. And as part of that, we want to also understand the energy balance at the snow surface. So that's where that albedo and a lot of the optical remote sensing comes in. So we're going to just a quick little outline for the next 20 or so minutes. I'm going to go through just a couple SnowEx slides just to remind you about SnowEx before we do a little screen break, not with slides. And I'll ask you to just kind of walk through that with me. We'll talk a little bit about collaboration and team building, and then kind of get into sort of how do these pieces fit together, the in situ measurements that we make during these field campaigns, the remote sensing observations that get performed from various different aircraft or satellite platforms, and how that all ties together with modeling. And we'll do a little exercise to try to wrap our heads around that. And then I was going to spend a whole bunch of time on the 2017 Decadal Survey. I'm going to post that for you. It's a very dense document that has been distilled to both a long and a short version of slides. Even the short version is, I think, 40 or 50 slides. So rather than going through that, I've highlighted just a few of the key slides that we'll talk about, and then I'll provide you with that resource if you want to look into it in more detail. But that Decadal Survey is kind of how priorities get set for many of the federal agencies moving forward as we think about satellite missions. Okay, so just reminder, SnowEx is this multi-year, we're a coordinated airborne and ground experiment. You've been given a great tutorial on the ground observations from Megan. Today, you're going to be getting tutorials and presentations on some of the aircraft observations. And we really need to be able to do this in a very wide range of snow conditions. So that's just a review. I wanted to show this slide. So this is kind of just getting across the point that these SnowEx campaigns are really designed to test spaceborne snow concepts. So LiDAR, for example, is a great tool for us for calibration and validation, but we're not going to get wall-to-wall mapping with airborne LiDAR. And so that hasn't been a focus in particular for how we would transition that to space, but it's the most mature way that we can measure large spatial areas. And so it's our most powerful calibration and validation tool. Some of the sort of instruments that we're hoping to understand better about how they might work for snow are listed here. So NISAR is L-band INSAR. We flew some of that. That's launching in 2024. SBG is a really important hyperspectral imager that's going to help us understand that energy balance at the snow surface. And we're going to be talking about this sort of Earth System Explorer call for satellite proposals. which is kind of the next chance for snow to get a satellite that's dedicated to observing the snow-covered areas of the world at a global scale. And so we performed this big time series over the Western US. That's the data you guys are working with, that you are all working with. How does that fit into this bigger picture? And so I just thought I'd share this. This is a draft, but this was a draft that was put together in 2019 to give you a little bit of insight into sort of the planning process for a lot of these efforts. So this was the roadmap for the Terrestrial Hydrology program for NASA, and specifically for snow observations. So you can see on there, we did a big campaign in 2017. We paused for a year to do analysis. 2019, there was a government shutdown. 2020, we started the time series campaign and then got shut down due to COVID. And then 21, we continued that time series. We did a big experiment on Grand Mesa in between. Now we're pushing towards Alaska. Some of the pieces that fit in here are this SBG study that I'll talk about a little bit later, and this Earth Explorer mission proposal call. That a lot of this data that you guys are working with, that you are all working with, is to help us do a better job of understanding how we might observe snow from space. And then listed on there also are the THP ROSA solicitations. Those are the competitive calls for proposals that people submit to do snow-related work. The snow schools are listed on there. If you haven't been aware of the snow school, NASA and Quasi in partnership run a field-based snow school, and those applications typically come out in the summer, later this summer, most likely. We've got some community meetings listed on there, and then a hack week, which we did do in 2021, and now we're doing another 22. I'd like to see this happen every year, and so we're hoping that we can make that a reality. So I'm going to go back to just to kind of get a break here for a minute from the screens and do a little bit of an interactive activity. I want to talk a little bit about collaboration and team building. And so what I want you to do just for a moment is take a moment and just kind of look around this room. We're going to do an activity about sort of how this room is structured. And I want you to think about this community that we're building with the people that are here in this room. So take a minute, look around at some of your partners, try to make eye contact with somebody that you don't know. We're just going to kind of do that while I kind of talk you through a few things here. I would say that most of the people that I collaborate with right now are people that I met during a similar field effort called CLPX, the Cold Land Processes Experiment, when I was a graduate student. So the partners that you have here, you know, are some of the people that are involved in this project, and likely people you may, if you continue on in this field, people that you may be collaborating with. So I want to just invite you to, as part of what you're doing in your groups in particular, try to connect with somebody that you didn't know before SnowEx. That could be within your group or outside, and try to do that, you know, that's a little bit independent of work, right? Independent of what you're trying to do in your project. Learn something about the people that you're working with that isn't about the work that they're doing for SnowEx right here, to get that personal connection, because those personal connections are what are going to sustain your collaboration over the long term. So just thought about that. Okay, so now we're going to go into this sort of interactive activity and think about the differences between the measurements we make on the ground, what we call in-situ observations, right? These are very precise measurements that we make, but they're expensive and we don't get them everywhere, and we don't get them all of the time except at a few locations. And contrasting that with remote sensing, these snapshots that are very high resolution, large spatial scale, but we only get them, you know, at specific intervals. And they tell us something about the snow. And then modeling, which can completely fill that space of space and time, but we need all these other measurements to make sure that model is working correctly. So I'm going to have you so I'm going to give you 2 minutes, or sorry, 2 breaths first. So I want you to take 2 breaths and look around this room and just try to kind of think about what's in this room, both the community that we are developing within this room, but also just kind of how this room is laid out and how we're interacting within this space. Now I want you to close your eyes. Don't get uncomfortable. No one's going to move. So you're closing your eyes, and now your task is I want you to be able to estimate the temperature and the height of every object that's in this room, including the people. Okay? That would be your task. That's kind of an impossible task right now. And now I'm going to give you a tool. You don't get to open your eyes. You don't get to use your ears. We don't have sound from space in the way that we're going to be trying to sense the snowpack. I'm going to hand you a flashlight. But I'm going to tell you that you can only turn it on 10 times. So you get to walk somewhere in this room and turn on this flashlight. And then I'm giving you a thermometer. And again, your task is to know what the temperature is everywhere and the height of every surface in this room. Okay, so you get to make 10 measurements. At 10 small locations, it's a flashlight that doesn't have a very big footprint. Okay, that's kind of what our infrequent field observations might look like. Okay, now we're going to set up a weather station. Okay, now I'm going to give you a flashlight. You only get to put it in one spot, and you get to turn it on, and you get to measure the temperature in that spot. And now I'm going to tell you that I want to know not just the temperature and the height of every surface right now, but I want it all year. And this space is going to change throughout the year. We're going to have, this incoming group of people that are going to be taking classes here during the fall, and that's going to swell because it's Seattle and it's rainy and people get bored in the winter and they're all going to come to class. And then when it gets sunny in the spring, it's going to wane and you're going to lose a bunch of students and there's going to be less people. And that's going to influence everything that's going on in this room. The lights are going to go on and off. You're not going to be able to use them, but the lights are going to go on and off. That'll change the temperature and the situation in the room, and the people will come in and clean and do the carpet and everything else. Okay, so, and we're trying to keep track of temperature and height. Now I'm going to give you a remote sensing tool. You get to make an optical remote sensing measurement. You get to open your eyes once every 12 days for a second. Okay, now maybe you get to do it every day. You get to open your eyes once every day, but it's right in the morning when your eyes are all blurry and you can't see things very clearly. Okay. Okay, now we're getting more information, right? We can kind of develop some idea of what the furniture looks like in the room. If we turn on our optical remote sensing at the right time, we might get some sense as to how people are moving in and out of this room and what that might do to the temperature. Now, the modeling is going to be kind of how we tie this all together, right? The model is going to give us the ability to make an estimate at any place in the room and at any time. But we're not sure if we got to have all the processes right? Our confidence may be relatively low if we're looking. If we want the model to work up on that balcony and we've never been up there and nobody's ever made a measurement up there, right? Our model doesn't even know what balcony does to temperature or height, right? That's sort of a place that we haven't done any measurements. Okay, I think right now the snow, you can open your eyes. I think right now the snow community is in a place where we can't solve this problem with one sensor or one really fancy field technique or a model by itself, right? We're going to have to tie all of these things together. And a big part of what we're trying to figure out is what are the best flashlights? Where do we use them? Where do we stick the ones we can turn on and keep on all the time? And then how do we best take these snapshots that we get from the remote sensing? A lot of the field campaigns that we're doing, we're trying to target the process, not necessarily make this measurement over the whole globe, right? We're trying to say, do I understand how the temperature changes as the sun goes up and down and shines through these windows? Can I model that part? And I might be able to do that with a very intensive effort over a relatively short period of time. And then the model would sort of help me try to extrapolate that. So I'm really excited about the projects. We've got people tackling all aspects of this sort of 3 areas of in situ and remote sensing and modeling. We've got a modeling group. We have a snowmelt group. We've got some data fusion with the INSAR and the ISAT-2 stuff. We have some sampling strategy and sort of, how do the weather stations relate into the bigger picture efforts. What am I missing? What's the other group that the one that I was working with, right? So trying to predict the radar response from the observations that we have. Okay, so all of these little pieces we're trying to tie together. So now I'm going to go through in the last 10 minutes here just the Decadal Survey and try to give you a little bit of insight into this process. So thriving on our changing planet, a decadal strategy for Earth observation from space. So this was put out by the National Academies of Sciences, Engineering, and Medicine. This happens about every 10 years, okay? There's a lot of community input. There are lots of different organizations and scientists that submit material to this effort. And what does that do? That gets NASA to this place where they recommend specific flight program elements. So we're going to be talking a little bit about these 4 different categories. And then we have this sort of other thing over here on the side, which is the program of record. That's that we have an existing planned observations, which we need to complete and as they were planned. And we want to maintain certain data sets long term. It's very hard to answer climate change related questions when a lot of these satellite missions are designed for 3 years. That's the typical satellite mission is engineered to last 3 years. Often they last 20, okay? But they're designed to do at least 3. So we've got these sort of 4 categories. Designated is this sort of the larger missions that are the highest priority, right? Those are already getting funded. That's going to happen. We have the Explorer class, which is this element where there's competitive opportunities for these medium-sized instruments. So designated, and Sheldon can probably correct me if I'm wrong, but I think designated is $1 billion, $2 billion, kind of that range. Explorer is around 400 million, 300, 400 million, kind of that level. Incubation, I'm not sure the numbers on that, but it's smaller. And then venture is another opportunity that comes around that is for really low cost observations, maybe like 90 million kind of level sort of stuff. Okay, so what are the prioritization criteria? I'm going to go through this kind of quick because you have access to these slides. There's some science questions. There's kind of all these different priority or ways in which this group has looked at the potential opportunities for satellite observations of the Earth's surface and how are they going to rank these things. So things that complement each other. One of the big differences in this decadal survey is this readiness piece. Like, can we make meaningful progress regardless of the measurement? One of the differences with the 2017 decadal survey as opposed to the 2007 one, 2007 was all about the specific technology. This 2017 document is all about the thing on the Earth's surface you're measuring and less about the technology and the specific route that you're taking to accomplish that objective. So they targeted the observables rather than the technology. Okay, so this is kind of the input that came in. There were a total of 290 community RFI responses. That is where the community gets to put in white papers proposing certain ideas. Then we kind of move up this task list here, and then again those targeted observables are at the top. Those are the highest priority ones. Okay, and I'm not going to read all of this. I'm just going to point to where snow fits in here, which is the very top bullet. So this is a summary of the top science and application priorities. And so snow falls in this coupling of the water and energy cycles, right? We in the Western US, 85%, 80%, depending on where you are, 75% of our water comes from the snowpack. And the snow really has a massive impact on the energy balance of the Earth's surface. So we definitely fall in that group, but you can see there's a lot of important things to observe of the Earth's surface, and these government organizations are looking at everything, right? And snow is just one small little part of that giant puzzle. Okay, so I'm just going to go through the ones that got chosen in each of these categories so you have a little bit of insight into what technology is going to be moving forward. Okay, so this first group is the designated. These are the ones that are already funded. This is going to happen, but these satellite mission timescales are long. They're 10 years, maybe a little more before the satellite goes up. So the reason you want to be aware of this is not so much that you might, jump into one of this early stage right now, but this is what's coming down the pike, right? For a lot of you that are students right now, you're going to have access to these data sets as you move through your careers. Surface deformation and change. So that's how the Earth's surface is how the height is changing for both earthquakes, landslides, ice sheets, permafrost. And I think our INSAR approach using UAV SAR and future NISAR, this is another place where we may get L-band interferometric synthetic aperture radar observations. Surface biology and geology, that's the big albedo one, right? That's the hyperspectral imagery. So rather than just measuring red, green, blue, or maybe you have 10 channels, now you've got hundreds, right? So hundreds of values of reflectance across the optical and thermal spectrum where we're making measurements for each pixel on the ground. That's going to tell us a lot about the snow surface energy balance. Mass change would fall under a lot of the stuff you should talk to Anthony about, but he's worked a lot on that problem from the perspective of how measurements of mass from space can tell us about the distribution of ice on the Earth's surface. Clouds, convection, precipitation, and aerosol. This is all the atmosphere, right? We care about that too. So all of these things have the potential to impact your research. Now the Explorer class. This is where snow is very specifically called out. There are 7 of these Explorer observables that get to compete in a proposal call that's coming up for this kind of 300 to 400 million class satellite. And 3 of these, or maybe 2 of these, will get chosen. So again, we're not at a place where we're definitely getting a snow satellite, right? There's a lot of important things that need to be measured about the Earth's surface, but we've got this specific call out here: snow depth and snow water equivalent, high spatial resolution in mountain areas. Some technology has been stated there, but I mean, basically everything's on the table right now. So, so that's just something to keep in mind for where that fits in. Okay, and then we've got incubation, and I want to make sure to not go over time here. But the other one I wanted to point to here, so this is the one step down from the Explorer class, surface topography and vegetation, right? Another place where we may get radar or LiDAR that could benefit the snow community. So hopefully you have just a little bit more of an awareness of kind of how these things move forward. The proposals for the snow target there are ongoing. There's several groups submitting proposals. I think the sort of timeline of that is probably like a January submission, in the next year, right? Those proposals will go in, but it's a long process. There's various different stages that those mission concepts have to jump through. As long as we get one of these through that first gate, we're likely to be doing a whole lot more of this kind of SnowEx type experiments. And as a community, what I'd like to see is that we rally around whatever snow concept moves forward. So there's going to be a healthy competition at this initial stage, but then we want to be supportive of what's next, right? This is our chance for a snow-specific satellite. And now I'm thinking about those of you that took the time out of your schedule to travel overseas. Thank you very much. Appreciate you coming here. And folks that have connections in these other countries are likely the reviewers of these, because there's so much conflict of interest throughout the community, are likely going to be people from international institutions. So getting you more familiar with the types of snow observations that we're trying to make and the kind of progress we're trying to make specifically with open science, I hope you can, take that back to wherever, not just the international folks, but wherever you came from to come to this Hack Week. try to communicate how this is going to help your research, how open science in particular is going to help us all get familiar with as many of these different possible observations that we may get, right? We may never get the perfect one for snow, and we know there's not just one that's going to solve the problem. So we're going to have to combine data from lots of different sources. And I would say that you know, if you look back historically, a lot of scientific communities, but the snow community in particular, people have built kind of silos a little bit, right? And we're trying to break those down through open science. If we want to fuse data sets together, we have to collaborate. There's no way that you can get to a point where you're an expert on more than one of these very complicated techniques, as you'll see as we go through these more complicated airborne aircraft instruments. But through this open source, open science process, you do now have the tools to grab a lot of these data sets and start working with them. You didn't have to spend your career building up a group that could do that. And I would say a lot of the groupings that's happened that way, you know, often they would have had, and I'm talking decades ago, would have had some special access to a data set or a computational resource or a code base that was maybe not openly shared. And so that meant that they were the ones that you had to work with if you were going to work in that area, which is okay. And they built up a lot of expertise. But there is this aspect, if we open everything up to everyone, that ability to compare, cross-compare between different instruments and try to solve this super complicated problem like the one I illustrated to you when you closed your eyes, we are going to have to all work together to make that happen. And that's what I got. I think we're right at time. I'm definitely around for questions and things. You can maybe take a question or two if there's one from the audience or from online. Feel free to push anything into the Slack. And happy to discuss this more with anybody.
Questions or comments for Steve?
If you need some time to digest, come find me later too. Yep.
Maybe going back to the community aspect, I was wondering if you have any kind of guidelines or tips what we can do to break down the silos to really go out and just get a bigger, broader community. Because I like that aspect really.
Yeah.
And I guess it's, we all see it, right?
I'm honestly, I think that's what SnowEx Hack Week is doing. And that's why I'm really excited about this particular event. I think a lot of these field efforts do that too, right? When you spend time in the field with somebody, you get to know them in a different way. I was talking to Frederick about how he made huge inroads with a lot of the oceanography folks here at University of Washington because he went out to sea with them and he had meals with them and he got to know them. And that's the kind of thing that always happens in a field-based setting. We work as a team and we get to know each other personally really well. There's no reason that can't happen in this kind of environment, right? We don't need to be in the field. We just need to take an interest a little bit beyond just the work, right? So I think that's one piece. I think the next generation is doing it. I feel like, you know, a lot of the folks in my generation maybe just didn't have access to a lot of these open tools that are getting promoted in events like this. And so it was very hard to collaborate. There were a lot of barriers to collaboration just because of the technology itself. You know, we didn't have Zoom, we didn't have a way of easily sharing code, that kind of thing. And so that's just sort of the way things evolve. But I think the more everyone in this room can promote this idea of sharing, the more we're going to make big advances there. Now, the one caveat, like just so that everyone's aware, is when we're in these competitive mission proposal stages, there are going to be aspects that we can't share, that the different proposal teams just can't share until we get past a certain gate, right? So just be aware of that. You'll get some exposure to some of the technology that's going into these proposals, and just know that there's hopefully a good chance that some of that is coming. And although it's only 3 out of 7 that out of this previous slide that are going to get funded, if we happen to not make it if one of these efforts for snow depth, snow water equivalent satellite does not make it this round, it's going to be even higher in the 2027 Decadal Survey, right? Maybe we jump into the designated mission and now we're not thinking about a specific technology. We're thinking about maybe multiple technologies, potentially. And that time frame is where many of you that are graduate students right now will potentially be even more engaged in this next step of satellite proposal development. I'm going to be on a beach somewhere. Any other questions before we